Hi, the purpose of this short video is to help you to determine the latitude and the longitude of the map boundaries on a topographic map. Here we're looking at just the very bottom half of a topographic map. This one is of the Austin East area in Texas. And when we look at a topographic map, we can see the latitude and longitude noted in the corners of the map. Notice that I see two numbers. In the southwest corner, I see 30 degrees 15 minutes, and I also see 97 degrees 45 minutes. If I scroll over here to the southeast corner, I also see two numbers, 30 degrees 15 minutes, and then 97 degrees 37 minutes 30 seconds. Notice that in both of these south corners, the numbers that are the same are 30 degrees 15 minutes. See how that's the same? That tells me that that is the latitude of the southern boundary of my map. Remember, latitude measures how far north or south you are from the equator. So I could say that the southern boundary, the latitude of the southern boundary of this map is 30 degrees 15 minutes. So that means that these other numbers are telling me something about the longitude of the map boundaries. And in this case, the longitude of the west boundary of the map is 97 degrees 45 minutes. And the longitude of the east boundary of the map over here is 97 degrees 37 minutes 30 seconds. Now I can scroll up too and see the top of the map and determine the latitude of the northern boundary. And do you see which numbers are the same here? This one is 30 degrees 22 minutes 30 seconds. It's the same over here. That's telling me that that is the latitude of my northern boundary. The next thing to consider is how much latitude and longitude is represented by this topographic map. If you notice up here in the name of the map, this is called a 7.5 minute series map. That means that there is 7.5 minutes of latitude and 7.5 minutes of longitude recorded on this map. And an easy way to see that that is the case is to take, in this case we'll look at the longitude, so the east boundary and the longitude of the west boundary, and compare those numbers. Remember, the longitude of the west boundary is 97 degrees 45 minutes. The longitude of the east boundary is 97 degrees 37 minutes 30 seconds. If I subtract those two numbers, I will get 7 minutes 30 seconds. That means that this is a 7.5 minute quadrangle map.
I wanted to add a little bit to the video about more detail about how you determine latitude and longitude on a 7.5 minute topographic map. So here is the map that you will be looking at in class. This is the Caledonia quadrangle, and what you saw in the video was that the latitude is located here. This is 43 degrees 0 minutes north of the equator, and that is replicated here, 43 degrees 0 minutes north of the equator. So if we go to the southern margin, you can see here the latitude is 42 degrees 52 minutes 30 seconds north of the equator, and then that's also over here, 42 degrees 52 minutes 30 seconds north of the equator. So it should make sense, right, that the numbers for latitude increase as you're moving further away from the equator. So here again we have 42, 52, 30, and then we go from 42, 52 up to 43, which makes sense. Again, we're moving further away from the equator. Conversely, the margin of longitude on the eastern portion of the map is 77 degrees 45 minutes west of the prime meridian. And then if we go to this corner, as we move further away from the prime meridian, which is in England, we hit 77 degrees 52 minutes 30 seconds west of the prime meridian. And then if we go down to the southern portion, again you can see here we're 77 degrees 45 minutes west of the prime meridian, and 77 degrees 52 minutes 30 seconds west of the prime meridian. So I wanted to, the most important part of this video is that there's a lot of unnecessary information that you're going to find around the margins of the map. And that's because latitude and longitude is only one system of location and there's multiple on your maps. These are actually UTM. UTM is a much more precise system than latitude and longitude, and it's used by the military and sometimes in other groups, but mostly the military, where precision is very, very, very important. So I wanted to draw your attention to a couple things. All of the numbers on the side of a lot of the numbers on the side of the map you actually don't need. So all of these ones with funny little superscripts you don't need. This one doesn't have a superscript, so this one you do need. I'm going to come back to this. And we kind of go up. Nope, nope, nope. This one doesn't have a superscript, that one we do need. We'll leave that one. Nope, nope. Nope, we don't need this at all, or that. And then we can do that along the northern margin too. This one has no superscript, we're leaving that one. So I'm just using like Microsoft Edge, which has, and I opened just the PDF that I have attached there, and it has this fun little drawing tool that I've never seen on another browser and is actually really handy for this video. So crossing all these things out. We're leaving that one. No superscript, so there's a superscript there and there. Oh, we leave that one. We don't need this, or this, or this. Oh, crossing things out is so fun. We leave that one because there's no superscript. And now we've made our whole way around. So let's look at the ones we haven't skipped. So we kept this one. And we kept this one. And if you look, it's along the longitude as we move further west of the prime meridian that these numbers increase. So we go from 77 degrees 45 minutes here. And this is a I'm going to do this backwards, sorry, of 77 degrees, 47 minutes, 30 seconds west here. So again, this makes sense because we're moving further west from England. So it goes 77 degrees, 45 minutes, 77 degrees, 47 minutes, 77 degrees, 50 minutes, west, and then 77 degrees, 52 minutes, 30 seconds west. So that is your 7.5 minutes of longitude, right? 45 to 52.5 is 7.5. So the same thing is true of latitude. Every 2.5 minutes, you, just like you saw here, 45, 47.5 to 50 to 52.5. Every time you go up 2.5 minutes of latitude, you're going to see one of those abbreviations as well. So again, here's 42, 52, 30, and here is 42, 55 minutes north. And then if we go up 2.5 more minutes, we should find 57.5, and we do. 42 degrees, 57 minutes, 30 seconds north of the equator, and 43 degrees here. So let's look at the same thing as we start from this corner and move west just like we just did. So here's 77.45. There's 77.47, 30. Here's 77.50 west, and then 77.52 west. If we go back down to the bottom here, we had 42, 52, 30. Here's 42, 55 north. So because this is right at 55 minutes, we don't include seconds. A lot of times you use the best information you can. Seconds are not something really to stress out about if you don't have to. Look at the guides that I'm going to show you in just a second. So if we go up from 55 to 57.5, there it is, 42 degrees, 57 minutes, 30 seconds north of the equator. Whoa, I'm going to erase that one there. Oh, so techy. Okay, so here's another fun thing. So we just wrote in 42, 57, 30 north. If you extend across, you're going to see these little plus marks, and these plus marks are important for dividing the map into 9 chunks, right? And so you saw that in part 1 where we talked about the central ninth, the north central ninth, and all those things. All of those are in relation to these plus marks which connect. Now this is going to be a real test of my skill here. Perfect. Across. So this is going to be a line of latitude here, 42 degrees, 57 minutes, 30 seconds. And it kind of goes from there, whoop, perfect, to there, and then over to there. So that's cool. And then you can go down also from 77 degrees, 50 minutes, right to the plus line. So this perfectly straight line that I'm drawing, oh, that was a good one. All spots along that line have a longitude of 77 degrees, 50 minutes west. And all the spots along this perfectly straight line have a longitude of 77 degrees, 47 minutes, 30 seconds west. And then if you scroll down, here is 42 degrees, 55 minutes north, and there's my plus again, so I'm going to connect across. Perfect, just like that. And then to this plus, and then over there. And then I can extend down from one plus to another. So again, this is 77 degrees, 50 minutes west. And here's 77 degrees, 47 minutes, 30 seconds west. You extend down there. So essentially what you're doing is you're turning your quadrangle into a tic-tac-toe board. Not only does it divide the map into ninths, which is very useful for kind of navigating around the map, but it also then gives you a chance, it gives you sort of a good guide to locating latitude and longitude. So what you'll see is right over here, this plus has a latitude of 42 degrees, 55 minutes north, and it has a longitude, and you always put latitude first, it has a longitude of 77 degrees, 47 minutes, 30 seconds west. So this allows you to make more accurate determinations of latitude and longitude. And it also gives you kind of a guideline also. If I asked you what like the latitude and longitude was of this location, you would start by going over to the side, and you would say, okay, so here's 42 degrees, 52 minutes, 30 seconds, and here's 42 degrees, 55 minutes. So you might estimate this location here to have a latitude of 42 degrees. Now I'm looking for a number that's between 52.5 and 55, and it's closer to 52.5. So let's say that, and you don't have to really estimate seconds for this. So let's say, just for the sake of argument, that it is 53 degrees north latitude. There is some wiggle room in your estimates for latitude and longitude. They just have to be reasonable. And then if you go south here, to find the longitude of it, you're going to find that the longitude has to be between 77.4730 and 77.50. So let's say that this is 77 degrees, 48 minutes, and it's probably a little bit more than 48 minutes. So let's estimate that it's like 30 seconds here, because that sounds fun. West. So that's how you estimate a location that doesn't fall directly on one of these lines of latitude and longitude. So you look to, and again, you ignore all of the little marks all around the margins, and use it as a guide to figure out your latitude and longitude. And this should look familiar. This was on part 1 of your assignment, where you see that this is the central ninth, this is the north central ninth, this is the northeast ninth, this is the east central ninth, this is the northwest ninth, this is the west central, whoops, there we go, west central ninth, the south central ninth, the southeast ninth, and the southwest 9th. Alright, latitude and longitude is your friend. It helps you find your way around the world. Have a great time.